Hello, hello. Welcome back. It's been a while, but I'm back finally, back to work. And as usual, we have a lot of stuff to do. Let me just quickly check if it's really live or not. It looks like it is. That's a good news. Especially after I did some tweaking to OBS Studio and to the stream in general. So there is a small chance that it will break at some point, but so far so good. Well, anyways, while I was away, some of the parts that we have ordered before arrived. So today we have the opportunity to finally check the other type of magnetic encoder that I was talking about. And let me quickly show you. It looks like this. So in a way it is very similar to the previous one. So that's the old one that I was intending on using, but this one is using I2C, and we can only have one in our keyboard because it has a fixed address, and therefore I can't use more than one, which kind of sucks because we need at least 3 of them. So that's a bummer. But then we have this one, and this is a different one. I think it's MT6701. Yes, I can even see the. I think I can even see the marking. Well, anyways, this one is not using I2C. This one has some fixed outputs that I was interested in, and I hope we can get a good signal out of it, something similar to typical encoder like this one, because this one has A, B, and I think Z and some other stuff, but looking at the schematics, at the diagrams, it seemed like it's outputting wave similar to this, what this one is outputting. So maybe we can get this one to work without any issues. The problem with it is that, of course, it needs power, so that will be a little bit more wires. And when I'm looking at it, definitely we can't use that for our horizontal encoder, which we are trying to substitute. If I can find one anywhere. Oh well, it just vanished as everything else over here. Maybe I have it here. Let me check. Nope. Okay, I will use the one that is still alive. So this is the encoder that we are trying to substitute with something else. And we were also trying to get something slimmer than this. So before I left, we arrived at this solution. So, and this is my response to this type of an encoder. And I managed to cram in 4 keys into it, maybe 4 switches, or push buttons actually. So the idea is that this is supposed to be volume knob. So hopefully we can use those 4 buttons. It has a really nice click. I really managed to nail down all the tolerances, so it is kind of okay. So only thing to consider is that since there are 4 keys here, so this exceeds the number of pins that I have available, and therefore we might be forced to abandon this idea, abandon those all those keys, or maybe. Oh, anyways, today before we jump onto this, because I don't want to waste too much time. So before we start digging into this one, I would like to change this encoder. Oh, now it's holding so strong. So I would like to do one more design, but put one of the push buttons underneath the encoder that sits inside. So this way we might be able to just have just one, so that will be used for mute, and that should be okay. And yeah, so this is how it looks like. So we have those very tiny mouse encoders. These are 5 millimeters. They fit pretty nice. Let's see if it has any like a wiggle room. Yeah. So the fit is kind of perfect for that. I even had to bend the legs to make it fit inside. Oh, that's fine. This doesn't bother us at all. So what I would like to do, I would like to try to fit one push button over here, so it will be sitting underneath this, and while this one will be printing, we can take a look at the magnetic encoder, see what it can output, if we can read that. We have a keyboard kind of mock-up ready for that. And one more thing, I also received these tiny bearings. Oh, they are so small, my god. Yeah, I don't know if you can see that. Yeah, it's very small, very tiny. So I was planning to use them for our horizontal encoder. Later on I can show you, because we already have like a rough idea how to do it, but now with these we should be able to do some like real-life testing and see how all those things fit. Okay, so without any further ado, I think we should get to work. We're gonna start with this thing, and then we'll move on to this. I really hope it will be working without any issues, since the signal is kind of similar, so maybe we'll be able to read that. That would be cool. If it doesn't work, then it's not cool. I don't really know how to push it further, but we're gonna worry about that later. So first thing first, let's see what we can do with this one. Okay, and we are back to our favorite CAD. Okay, so this is our design for 4 push buttons. I also should have the one for horizontal somewhere over here. There's too much stuff as usual. I think I already made a I already made a design in my spare time some time ago for this new one. So this is kind of nice. Okay, so we do have a push button placed already at the bottom. I think we had like almost finished design for this. Let me just quickly find where is it. Okay, so yeah, we had this one. Okay, so this is our design for the current one. So I think what I'm gonna do, I'm gonna make a new element, and then we can do 5 mm push button. So let's call it mouse horizontal encoder, 5 mm, and let's make it push button. So we have the harness over here as well, but we're gonna only copy this, 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 and also this one, and this one. Okay. But I also have the holder for the legs somewhere. Okay, so we need this as well. Okay, doesn't look that bad. Is there anything else that we might be needing from here? I don't think so. These are only for the push buttons. So I think that will be it from this part. On the base, we don't have really many things. Okay, so it would be nice if I had a design for the horizontal, for the mouse encoder that is 5 mm. So we can see more or less how it fits inside. Okay, here it is. Okay, so okay, let's take a look how everything is oriented over here. So we have the knob we've been using and the shaft as well. I think that's the shaft. Let's take a quick look. So this one goes here. Okay, it seems to be loose enough. So I'm hoping that when we put the push button underneath, it will have enough force to lift it up. Okay, but the question is, now we have it a little bit like floating on this. And if we want to push everything in, so then we would have to either have this part moving, because making the bearing move up and down, that's gonna be a little bit tricky. Okay, anyways, if you look at it now, so the shaft doesn't really go through. And I think that is even okay, because we would like to push the whole thing. So also probably you can see, but I think we need to extend one of the parts so that we have this the shaft has this thick element over here. So I think we have to extend it all the way to where the encoder is placed. So that will be the part that will be actually pushing the encoder against the push button over here. And if you take a look how the whole plate is designed, I think I was using this one. So this is the bottom part, and top looks like this. We can make a plane and move it towards the center, and then from this plane maybe we can slice it like this. Okay, so this is how it looks like. So we have to move this part all the way to where the encoder is, and then push button needs to go up so that but technically maybe we can extend this a little. Would that work? No, most probably not. I think we need the whole push button to be over here. Okay, that's gonna be a little bit tricky. I don't really have much confidence in this design. Okay, but anyway, so I can select this, the top of the push button, and I can move it all the way to here. But now the question is, how much space do we have left? Okay, so what's the distance between these two walls? Okay, it's 0.1, so it's not that bad. So what we can do, I think I hit something different. I hit one of the lines, but that's fine. Let's do rectangle on this plane. Or maybe not even rectangle. Maybe we can offset whatever the push button is. So let's make it 0.1. Okay, we can hide it. And let's pull it all the way to here. So this will remove everything. We have to still modify the shaft. Well, I see the shaft is kind of sticking out over here, but it's not sticking out in reality. So let's maybe take a quick look. Okay, so this is a different shaft. So this shaft is not really from this design. Okay, we have another one. And okay, how does it go? How far is it? Okay. Yeah, so this one looks about right. I think that's how I saw it, like picking. What we need to do, we still have to move this part, the thicker part. We still have to move it to here. I think I can I can select this wall from here. So if you have a design that is like that and you would like to select this wall, so you don't really have to rotate or do all this kind of things. All the hidden walls, you just have to hold Control and just scroll up or down. So it will select like various things that are like obscured from the view. Okay, so now we can move it and all the way up to here. Actually, I think I'm gonna change that because this is a different design. So I think I'll remove this knob. It will be a separate knob over here. So we have these two things. And we have the shaft as well. So we'll just move the shaft from here to here, and we can remove that. So our previous design that we were planning to use for the volume, so I will keep it like that because it was quite okay. I mean, maybe it wouldn't hurt if we make it all the way, like reaching to the encoder. But I'm gonna keep it like that, at least for now. Maybe it's like something that we can improve in the future if it needs any improvements. Maybe I will make it like 0.1. So it's not really touching that much. It should still be able to press the button that is over here. Looking at it now, it still looks kind of chunky, but with those tiny bearings, maybe we can redesign it somehow. Just use the small bearing. This is 3x6 by 2 millimeters, so it's super tiny, and that should be enough to allow to rotate. So yeah, maybe something to check later, or maybe off stream, see how it goes. Okay, so we have this shaft touching, almost touching. It's 0.1 away from where the encoder is. This design is not perfect, so it might be touching, it might be a little further away. Anyways, this should be good. So now we need a way to attach the push button from the bottom. So we were using this as the bottom plate. Okay, and okay, so I think I will also need to make a new bottom. This one will be just to try, so it can be a bit junky. Of course, that's the theme of the stream. We need some junk just to see if it's possible to press it, and if it gonna work, I think we can just make it a little bit better. But right now I'm only curious, like, if it's gonna be possible to even like press the whole thing. So let's call this part bottom. And we're gonna steal from here. We need this, this, and this. Okay, we can leave this design. All right. So I think what I will do, I will make holes over here, and there will be another plate at the bottom that will be holding our push button. At least this is how I envision it right now. Okay, let's make those holes over here. Okay, so that will be the bottom part. I mean, maybe not bottom part, because now it will become the middle part actually. So that's fine. I think we need to cut the hole. So our encoder will fit in. So we can just follow the same hole that we did for over here. Okay, let's hide all of that. Okay, and we still have a plane left. Okay, so our button will be over here. And we have our knob as well. So the idea is that we press the knob and it will push the button over here. So, okay, we need some more space from what I can tell, because we still have the legs from the push button. Let me quickly check, because I'm not quite sure if this is the right size. Okay, so this is the size between the legs, so it's 3.78. Okay, and the distance over here is how much? 6.2. 4.5. Okay, so technically, okay, but this is, we can also bend them a little. I think that's what I did, just to make them hold. Okay, so if I make this hole bigger, I can move it around. Okay, let's make it maybe 0.4 from the wall, like so, and this one as well. Okay, 0.4, 0.4, 0.4, and this one as well, 0.4. This and ruler, and I want from here, I want 0.4. Okay, looking at it. Okay, I think I will just add some more over here. Okay, let's make it 0.4 from this imaginary leg, just to be on the safe side. Okay, looks like enough space. Okay, so what I want to do now, I want to add, maybe I should rename this to middle. And I would like to add one more part that will be called the bottom. And okay, what we can do over here, let's copy and paste this one. So this one was more or less how the legs were wrapped around. Okay, but we don't need it this big and we need it a little lower. So first thing, I will anchor it over here and drop it all the way down. And now I would like it to be the size of the push button. Okay, like so, this should be fine. And as I said, we don't need it to be this thick. Maybe if we make it like 2.4, just to be safe. Okay, so now I will copy this plane and move it up. I would like this plane to align with this part. And how far are we from here? Okay, 1.6. So I think I can pull it to here. And what we need to do now, I think I will just try to project this wall onto this, because what I want to do is I want to connect this wall with this wall. So then we will have something like a lid from the bottom that would close it. I mean, at least at this point, it looks like a design that might work. We will find out soon. Yeah, but I can project. I think that was this one. Project to sketch. Okay. Ah, no, sorry, not this one. It's a body project. So we need to use this. And we can choose the direction. So we want to project like here. And we can select target faces. We want this one. Okay, and we have it like over here. So now I can pull this to here. And we have it connected. And actually, I can even go further. And I think I can pull it all the way to here. Yeah, it won't hurt anything. Oh, we can leave it like that. We don't have to fix it. But what we have now is that we have like two bodies that are almost like identical. With the difference being that the one is touching the button and this one is not. Okay, so let's move it up. Okay, how far is it from here to here? 0.8. So if you make it 0.8 like this, and now if I anchor to the top and I move it to here, okay, now they should not be like one into another. So this is one body and this is a different body. Okay, so more or less so if we take a look at the top, maybe I would just move the top as well, so that would be easier to manage. I don't think I'll be making any changes to the top. This can be removed because it's empty, and we don't want empty bodies. I mean empty, or you can call it empty body because there was nothing over there, our empty group. So the top I'm gonna take from here as well. Oh, that is a lot of stuff. I see. Yeah, maybe I shouldn't. Okay, but the question is, okay, we need it to be different. We don't want it to be like that. Okay, looking at it. I think we should go back to one of the earlier designs. Yeah, because we don't want it to move like this. We want to move it like that, up and down. So we had this previous design that was a good holder actually, and the push button from the bottom should give like a bit of a distance for it. So maybe this will work. So this design is good for 4 buttons because it allows for the knob to like move a little, like a wiggle around. It's still okay to rotate, but we can also push 4 sides, so that was okay, but this won't work for what I want to do now. Okay, so this is the most recent design, and this is another one, and we need neither. Okay, so I'm gonna steal this one for the top. Oh, I don't really have to bother removing those holes. I can leave it like that, or maybe we'll remove. Might be faster if the printer doesn't have to like slow down to make a hole. Okay, we still have our bearing mount. So I'm gonna copy this to our top. Okay, so if you wanted to be able to press, I think we have to lift everything up a little. So this will include the encoder and the push button. So maybe we can do it like how much does it push? I think it was something like 0.4. Let's give it a shot. Let's give it a try. Okay, so this is, when not pressed, it's 4.9, and when pressed, it's 4.65. So 0.25. Yeah, more or less 0.25. So I think we should lift everything up by 0.25. So everything will be resting on the push button, and then when I press, this should go all the way down. This should be able to press the push button. So maybe we can make it even more. So maybe like 0.3. So then even when pressed, there will be still a little bit of a distance left. Yeah, that makes sense. Or at least it sounds like it makes sense. What? Okay. Okay, so for now, let's hide the bottom. Okay, so the knob will stay the same. The top plate and the bearing mount will still be the same. Okay, but at the same time, the bearing is not really moving that well on this holder. Okay, maybe I should change the holder as well. And maybe I should change it. Maybe this one is not the best. So many choices. Okay, so where are we? So we have to move our push button up by 0.3. It was 0.25 and oh no, so maybe more was 0.25, and you want to make it so it should be, I think we should make it a bit more. So maybe 0.4, 0.5. So we will have like 0.2 still left after we press. Okay, we can hide the encoder. So this one also minus 0.5 and this one also minus 0.5. Okay, now going back to this part for the bearing mount. So this one is not really good because it's not really moving. I think I will just remove it, and we have to go back to one of the old designs. How about this one? But I will only take this part and this part. Yeah, now this should be okay now. So that was holding quite well. Okay, let's move those holes. Okay. So, okay, so we moved the shaft and we have moved the push button. We don't have to touch the place where the encoder is resting. So nothing is changing here except for, okay, except for this. Okay, so we have moved that higher. Okay, so what we need to do now to make it work? Since we have moved the push button up by 0.5, so we should also, I think, move the bottom part of the holder by 0.05. So we have to move everything like that. Okay, so I think that should work, but now comes the middle part and the bottom part as well. So the middle is over here. So I think it should be okay if I just lift everything up. And also the very bottom. Let's do some ordering over here. So we have top, we have the knob, then we have the harness that is holding the encoder, and then we have the middle part and the bottom part. So it's easier to navigate. Okay, so I will hide this one right now. And as you can see, we are a little bit off. Okay, so this should be good. Okay, so how does it look like? It doesn't look good, I know. But if we look at it, if I can find the bearing itself, that would even put a little bit more light onto it. So where is the bearing? Oh, I think it's here. Okay, it's nice. And we have this plane. Maybe we can slice it. Ah, perfect. Okay. So we have our knob over here. We have the shaft. And I forgot to show the... Okay, now it's better. So we have the encoder over here. So the idea is that we should be able to... The bearing, actually it should be holding onto this one, onto the knob. That is interesting now. So because I want to be able to push it like down, like this. Okay, so we have this holder, but the holder will be... I think I should also lift it up by 0.5 since everything will be higher up. Otherwise, we will end up with the push button always being pressed. But how to how to make this part work so that we can move it up and down. Hmm. That is interesting right now. Maybe one more look. So we have the bearing over here. So it's it's holding actually on this holder. So the holder won't let it go up. So if you extend the holder a little bit, then will I be able to press it or not? Hmm. Well, we need a way to be able to move it up and down, but at this point, I think that it won't be really working like that. Okay, well, it is moving a little on this, so maybe it's not that bad. Yeah, and maybe I don't really need to extend these holders because we have those these bumps, so that should be enough. Okay, I think I will give it a shot like that. So without any changes, I will just assume that this will work. Most probably it won't, but who cares? Should be fine. Okay, so from like a general point of view, this should be okay. So we have the bottom part that will hold everything together. We have the middle part. Okay, if I remove the button and if I remove the encoder, so this is how it's gonna look like. Okay, I guess I will take the risk and just print it, and then we can adjust further. Okay, so I will start with the knob. Actually, knob should be higher. So we have the knob and then we have the top. All right, so let's export this one. We need a fancy name for it, so let's call it 5 millimeters. Push button down, and that will be our knob. Okay, this is our top part. So we have 5 millimeters push button down, and we call it the top. Then harness in the middle. 5 millimeters, push button down, and we call it the middle. And the last part is the bottom part. Okay. I have Bamboo Studio already opened, and as usual, it wanted to update itself just shortly before the stream, and of course I didn't allow it. Okay, so we can start adding parts. Okay, let's see how it's going. Okay, so the arrangement is okay. I think all the parts should be fine to print. Yeah, it looks about right. Okay, I think these parts, they might be needing some support. Let's see if it changes anything. Okay, I think I will just leave it like that. Not sure if it's gonna help because they come out a little bit scuffed, something like this. So you can see that there are some artifacts. We'll see if adding the supports help anything with that. It's not an issue. It doesn't have to be perfect right now. Okay, let's go with the print. Let's take a peek at the printer, what it's doing. Okay, so this is printing right now. So it's gonna take a while. Okay. So as promised, I think we can take a look at this little fella. Okay, here is our magnetic encoder. Okay. But before we do that, I think we need to take a look at this spec sheet. Update complete. Oh, awesome. Oh, so there's a library for it, for Arduino. Oh, that's cool. Is this the data sheet? Yes. Okay, so The outputs I was interested in are these, or more like A and B. Okay, so we have A and B over here. It's cool because it can also detect something like push. So if the magnet comes close, it will actually read it as a push. So rotation is one thing, but it seems like it can also tell when the field is getting stronger. So then it will register this as a push, and this is kind of cool. This might help with our volume encoder, so we don't really have to stick anything underneath. This might be able to read that. Okay, so what we have here, we have VCC, out we are not really interested in, and we have ground, so these two, and then we have B and A. So that's about it. And here is our keyboard with all the stuff that we need. And the cables that we don't like to solder at all. Okay, I already forgot which pin was what, but we can check later in the source code. But for now, I think I would just solder this stuff. So let's follow the rules. Let's make VCC red and ground black. All right, well, there are two VCCs over here. And two grounds. I would assume they are connected somehow. Okay, so let's see if AliExpress has any hints how to connect that. That's not the same one. This is the one. All of them are different. Okay, honestly, I have no idea why this one has so many VCC engine and ground. I'll just assume they're all the same. What can go wrong, right? What can go wrong? Okay, so I'm gonna use this for VCC, and ground is over here. Yeah, awesome. We can't even solder to this wire anything. Somehow it holds. Barely. And this one doesn't. Maybe I should just solder straight to the MCU. It seems like the tin is coming through the holes, and that's why it's not holding. So maybe a little bit of Kapton tape will help. Okay, one more try. Okay, that's it. Not sure what's wrong with those cables. Are they like dirty or what is wrong with them? But soldering this stuff is a waste of time. Okay. I have better ones and we can just do it straight to the MCU. That should be fine. So we have our VCC. Ground. And two random ones. For the signal, just cut them to the same length. Okay, I see that the printer is halfway done. That's gonna take a while. Okay. I hope this will be better. Okay, we have ground and we have VCC. So we need A and B. Okay, somewhat it's holding. Okay, so our VCC we can take from the raw output. And the ground is just next to it. Okay. I need to quickly check how did we, I mean, which inputs were chosen for the encoder. Okay, D1 and D0. I think it was 2 and 3. Yes, D1 and D0, so 2 and 3. Okay, so I remembered correctly, which hardly happens. Let's put some tin first. Okay. So, moment of truth. Okay, so I'm gonna connect the keyboard right now, and I hope it won't kill the stream. Okay. Oh, so it looks like it's outputting signal all the time. That is not good. So it was like behaving as if we were pressing A and B all the time. Yeah, as you can see, it's like going crazy. So adding magnet doesn't really change much. Oh, it stopped. So not quite what I was expecting. So if I move the magnet close, it kind of stops outputting. I wonder how it's gonna look like if we open like Notepad maybe. What will be the output like? I hope you can see the font. Okay, so it goes crazy right now, A and B, A and B. And if I attach magnet to it, oh no, it doesn't really stop. I think it affected the whole PC. Okay, looks like I almost killed the stream. Or actually, I did kill the stream. Okay, finally. Okay, so not quite what I was expecting to get out of it. Okay, so looking at it now, it says that the one over here, it is guaranteed that one Z pulse is generated for every rotation. Yeah, but that's kind of odd because there was no magnet rotating around it, and it was still generating output. And it actually almost killed the stream because it was pushing so many letters. Okay, because looking at the schematic, so pins 6 and 7, so we have A and B, but there is also I to C over there. And how does it know which one is which? Like, how can we tell if it's, maybe it was going wild because we got clock over here instead of like B? How do I configure this to work as a ABZ instead of like I to C? Okay, so the diagram is a bit different. So for I to C, we have pull-ups over here. This was only recommended. Okay, and for ABZ, okay, we have nothing. So technically it should work. Okay, this is A, if you want to go ABZ and the push button, so 1 and 4 to VDD. Okay. So let's take a closer look. Okay, I for a moment I thought that YouTube stream died completely, but seems like it's fine, and Twitch seems to be working as well. Okay. So I think we have this diode over here, just as they recommend 6 volt. So this one is between 1 and 4, and I think there's also a capacitor over here. Yes, there is. So this should be okay. Okay, let me take a look. I still have the order somewhere on my phone. Okay, so not quite sure I'll be able to show. Nope, it won't work. So there's a tiny okay, so it looks like there is a way to short something over here. Ah yes, over here it says I to C, and what they say here, so looks like by default it's running in I to C mode, so that would explain why we had so many letters output, because one was the clock, so it was like outputting all the time. I don't know what happened with the data. Maybe it was also sending some data, because so that's why it was going wild, most probably. So I think we have to short this to disable I to C. Now I'm scared to connect this again. If it keeps going crazy like that. Okay, so we need to short that pin. If I understood correctly. Okay, so we are back to the testing. Okay, let's see what happens now. I will just... Nothing happens. Okay, so I guess that's a good sign, at least for now. We have no output, but we don't know yet if it's because it's not working at all, or is it because we just switched off I to C. And I can see that the printer just finished, which is great. Okay, we can hide that. Okay, so let's see what happens if I take this. I have a magnet over here. Okay, I think we have the focus. And nothing happens. How cool is that? Do we even have a... Okay, we have a focus over there, so that should be fine. But we have no output. Maybe it's a different magnet. Because I think these arrived with bigger magnets than the previous ones. Nope, nothing happens. Okay, that is not good. I think I have to fire up oscilloscope, because the fact that we have no output here doesn't really mean there is no output at all. Maybe it's not outputting the same way as a typical encoder, so the oscilloscope should show something, maybe to make a different output. Okay, the question is it even charged? Okay, it works. Almost dead. And it's not USB-C, it's some fancy stuff. Okay, maybe that would be enough to just take a look what's happening. And I will charge it off stream. Okay, so one goes to the ground. Okay, not much space, I hope. Okay, nothing is showing up. This won't work like this. We need some extensions. Okay. So let's see how it goes now. We have ground for the oscilloscope. And we can connect one of the outputs to the probe. Let's see what happens now. Nothing happens. Doesn't seem to be doing anything. Not quite sure what's wrong with it. Let's see. Let's connect to the output that can show like the push button. So instead of reading the rotation, maybe you can just see if it can even detect the magnet at all, if there's anything happening. Which one was it? It was it was push. Okay, so it's over here. So we have push over here. So yeah, let's solder to that. Oh, damn it, I forgot. Okay. I forgot to unplug, and most probably something just died. I think the output is fried on the MCU. I hope I didn't kill the oscilloscope. I might also kill the sensor as well. That's the issue with this soldering iron, that if you don't disconnect stuff, it might kill outputs. Okay, this is helpless today. Okay, at least we have the print finished. So I will just go and pick it up. Okay, so these are our parts. And before we even start doing anything, we can take a look. How does it fit? Okay, this looks promising for now. Okay, it's not bad. So it sits kind of nicely. Okay, this is very encouraging. Okay, let me just put the screws in. Okay, as usual, one is enough. Maybe we can get one from the bottom. Okay, so far so good. And let's see how it goes when we attach everything. So this is our knob. Yeah, it works. It can be pressed and it can be rotated. Okay, I forgot to remove the didn't really help much. Still some artifacts. Yeah, it's not much of an improvement, but still. Okay, but the good thing is that Well, I can see it's not really the thick part of the shaft pushing, but it still works fine, exactly how I wanted it to work. Okay, but the shaft is not really okay. Well, I can see that the bearing is not moving, so it's only the knob. So basically we don't really need this, maybe we don't really need this big bearing over here. We can maybe get away with the small one and just keep it stationary. I think I would need to print like a different knob that will sit tighter on the bearing. I mean, it looks okay, but it's not really the same movement as I was hoping for, because I was hoping that the bearing would be also moving together with the knob, and now the bearing is stationary and the knob is just moving up and down. So I need to reprint the knob. I need to make it like a bit taller, so that will take more of the bearing inside, because now the bearing doesn't really hold that well. Yeah, but I can see that there is not enough wiggle room. Okay, even if we look at it from here. Yeah, so the bearing is not really moving. So everything is kind of resting on the bearing. So if we keep the bearing stationary and just move the knob, because right now it's kind of okay, it's a good click. So if I was like rotating, it's a bit wobbly. Yeah, because it's not really holding that well to the bearing. Okay, it needs some improvements, but we are on the right track, so maybe this will work. Okay, so we managed to kill, I think the sensor is dead, most probably. Most probably also one of the inputs on Pro Micro is dead as well. So this is like a good how to call it? Good score for this stream. We managed to kill two electronic devices at the same time. Good that at least the oscilloscope survived. But the good thing is that at least we have this more or less working. So on the next stream, if I have the time, I will check what's wrong with the Pro Micro. I mean, if anything is wrong with it, most probably this one output is dead, so we'll have to maybe use a different one if that's the only damage. Also, if I have the time of stream, I will take a look at this encoder, magnetic encoder, what's happening with it, why it's not really reading anything. And of course, maybe I will try to reprint this thing. But my day tomorrow is a bit busy, so most probably I will have no time. So this is what we'll be doing on Wednesday. So yeah, looks like Wednesday is gonna be filled with positive emotions when we find out that like half of the stuff that we used today is dead. Oh, that's fine. I still have like two more magnetic encoders left. So right now it's not that bad. It's only 30% damage. So we can still go. Yeah. Okay. Thanks for watching today. I see you on Wednesday. Hopefully we can get some more stuff working on Wednesday and without killing anything. And by then, have a great day, have a good rest, and I see you all on Wednesday. Bye bye.